Hello and welcome to our screencast on Group 0, the noble gases, one of the groups that we have to study. We're going to start as we start every lesson with a retrieval practice. So I'd like you to read through the questions, then I'd like you to pause the video, answer the questions, and then come back when you've answered the questions. Okay, welcome back. Right, how are the elements in the periodic table arranged? They're arranged in increasing atomic or proton number. What do we call the rows in the periodic table? They're called periods. What does the row tell you about the element? It tells you the number of energy levels or shells of electrons the element has. What do we call the columns in the periodic table? We call those groups. What does this tell you about the element, the group? It tells you how many electrons the element will have in its outer shell. How did Mendeleev order his periodic table? He ordered his by atomic weight. Okay, so we're going to look at the properties of group 0 elements. We want to be able to state the names of the element in group 0 and their symbols. We want to be able to describe the trends in properties of the group 0 elements. And we want to be able to explain why group 0 elements are unreactive. Right, here are some key words and their definitions that might be useful if you want to understand what we're talking about in this screencast. So I'd like you to pause the video and read through them and then come back and we'll start again. So today we're going to be learning about the group 0 elements, which are commonly called the noble gases. The image below is showing what happens when you pass an electrical current through each of the noble gases. As you can see, they glow very, very brightly and they glow all sorts of different colours. And we can actually identify which noble gas we've got by their colour. So where do we find the noble gases in the periodic table? Well, they are the group on the furthest right-hand side of the periodic table. You need to be able to learn their names. So what I would like you to do is pause the video now, learn the names and the symbols for each of those elements, and then start the video again when you have learnt them. Okay, welcome back. The names are helium, neon, argon, krypton, xenon, and radon. If you have got them incorrect, I'd like you to just pause the video and just rewind and just learn those names before you actually go any further. If you do know them, then we can move on. Okay, so we're able to state the elements in group 0, sorry. I will be able to describe trends in properties of group 0 elements is our next one. So these are some of the properties that they all have. They are inert gases. Inert means unreactive due to having a full outer electron shell. They exist as single atoms. Now that's very unusual for a gas, right? Most of them go round in pairs like O2, H2, Cl2. They are diatomic. These exist as single atoms. They are non-flammable. Now, in order to be flammable, you usually have to have a reaction with oxygen. And as we just said, they are unreactive. They're all gases at room temperature. Now, most of the others certainly turn to solid as you go down the group. These are all still gases. Now, this is a picture of an airship called the Hindenburg, and it had a very bad accident, right? it was filled with hydrogen, which was our lightest element, right? So it therefore would float in air. However, it was a bad idea because hydrogen is extremely reactive, it's explosive. So now we fill airships with noble gases like helium and neon because they are famously unreactive. That's the reaction of hydrogen and oxygen. So as you can see, very explosive. Okay, so we're going to look at some of the properties of the group 0 elements. The first thing I want to do is just test to see if you do remember the symbols for those elements. The next thing is we're going to convert from a unit of temperature that we may not have come across before called Kelvin. Now Kelvin goes back to minus 273 degrees Celsius, right? And that is what we call 0 Kelvin. So all of these temperatures are in Kelvin. Now the difference between each degree of Kelvin is the same as each degree of degrees Celsius. So they go up in the same amount each time. In order to convert Kelvin to degrees C, you have to subtract minus 273. That is, you take 273 away from the number. So for instance, for helium, if I was to convert 4 Kelvin to degrees C, I need to take away minus 273. So that would come to minus 269 degrees Celsius. Okay, so you need calculators for this. Finally, I want you to tell me what the trend of the melting and the boiling points are. So you've got quite a lot of work. Pause the video now and come back when you've completed that. Okay, so let's see if you remember the symbols for these elements. Helium is He, neon Ne, argon Ar, krypton Kr, xenon Xe, and radon Rn. Now, in order to convert Kelvin to degrees C, we're going to take away 273. So 25 minus 273 is minus 248. 84 Kelvin is minus 189. 116 Kelvin is minus 157. 161 Kelvin is minus 112. And 202 Kelvin is minus 71 degrees Celsius. 4 Kelvin is minus 269, as we said already. 27 Kelvin minus 246. 87 is minus 186 degrees Celsius. 120 Kelvin is minus 153 degrees C, and 165 Kelvin is minus 108 degrees C, and 211 Kelvin is minus 62 degrees C. So as you can see, they're all below 0. So they turn to liquid and turn to a gas, all below 0 degrees Celsius. So that's why they're all gases. How do the melting and boiling points change as you go down the group? As you go down the group, the melting and boiling points will increase. Okay, so now we're going to look at the density. Air has a density of 0.0012 grams per centimetre cubed. Any gas with a density larger than this will sink in air, but anything lower than that would rise and float. First of all, I want you to describe the trend of densities of the group 0 elements. And second of all, I want you to look at their densities and say which ones will float, which ones will rise in air. So pause the video now and come back when you've answered the questions. Okay, describe the trend of densities of the group 0 elements. So as you go down the group, the density of the gases will increase. And that's true of most of the elements as you go down any group. State which group element will rise in air. Well, the two that have densities that are lower than 0.0012 are helium and neon. So they would rise and float, and that's why we use helium balloons. Okay, so that means that if you've understood this, you are able to describe the trends in properties of group 0 elements. So move on to our third success criteria, which is I will be able to explain why group 0 elements are unreactive. So what I want you to do, we're going to be pausing the video again, is draw the electron shells of helium, neon and argon. Now it would be good if you had a periodic table handy because you need to know the atomic number of each of those in order to work out the number of electrons that you are going to put on the shells. Okay, if you haven't got one, I'll tell you helium has 2 electrons, neon has 10 and argon has 18. Okay, once you've drawn them, I want you to tell me what you notice about their outer shell, and then try and use that answer to explain why the noble gases are unreactive. Okay, so pause the video now and come back when you've done that work. Okay, welcome back. Right, the electron shells of helium, neon and argon look like that. So helium has 2 electrons and they are on the first shell there. That shell holds 2. Neon has 10, so it puts 2 in the first shell and 8 on the second shell. Both of those shells are now full. Argon has 18, so it puts 2 on the first shell, 8 on the next shell and 8 on the third shell. And all of those shells are full. So that tells us the answer to the second question. What do we notice about their outer shell of electrons? Well, their outer shell is full. They all have full outer shells of electrons. Now, how does this explain why the noble gases are unreactive? Well, in order for an element to react, it has to want to complete its outer shell and make the same sort of electronic configuration as a noble gas. So it will give away, or it will receive electrons, or it will share electrons. Now the noble gases already have a full outer shell, so there's no need for them to transfer or share electrons. Okay, so they're unreactive because they don't need to react with any other element to achieve a full outer shell because they already have one. Okay, so we're going to do our final checkpoint. I want you to read the questions, pause the video, and use your knowledge to explain these 4 things. Why helium will be used in balloons, why it's a good idea to fill an airship or a zeppelin with a noble gas, why noble gases are very unreactive, and why would you put argon in a light bulb instead of air or oxygen. Right, pause the video now and come back when you've answered the questions. Hello, welcome back. Right, why is helium used in balloons to help make them float? Well, helium is used because it has a lower density than air, so it would rise in air rather than sink. Why is it a good idea to fill airships or zeppelins with a noble gas? Well, first of all, because the gases that you are going to use would have a lower density than air, so it will float, and also because they are unreactive, unlike hydrogen, so they're safe to use. Why are noble gases very unreactive? Well, they're unreactive because they have a full outer shell of electrons, so they don't want to bond with anything else in order to gain or lose or share electrons, because they already have a stable electronic configuration. Why are light bulbs filled with argon instead of oxygen? Well, light bulbs are filled with argon so that when the filament gets hot, it will not react with the air or oxygen, and therefore it won't corrode and break. So argon will not react with the filament and the light bulb will last longer. Okay, so that is our final success criteria. So hopefully you know a little bit more about the properties of group 0 elements.